It was going guys, Kins here. So it seems like I just finished the work on a mode generator for my chess program in 6502 to run on Kim 1. And it's quite a good news that the entire mode generator takes only 357 bytes. So now let's make sure what exactly is considered to be within those bytes. And I need to say that Oscar Toledo actually managed to write the entire program actually that was in x86 assembly, which was probably even a bit less for the entire program, not just for the mode generator. So this is not something special or anything. But just to give you an idea, so well, actually, I'm using the entire code. I'm uploading the entire code just to not mess it up with different parts, like the data part and the code part, because it's just easier and faster to debug. But anyway, and I will upload this all along, and I also do use some fake bytes. So the overall stuff is obviously more than 357. But just want to give you an idea where this number is coming from. So the actual searcher starts from here, and if I go to the very end, so this is the search. This is the search function. It doesn't yet make and unmake moves. It only can generate moves and marks those squares that are supposed to be the target squares for pieces. Marks them with a single bit. So if I just copy this, just want to show you how much bytes it takes. And if I just paste this in and assemble and upload, this is from the past. So if I just let me just to show you this really. So assemble, upload. Yeah, actually 357 bytes. And here, what is redundant that is going to be skipped. So this bytes for debugging this piece of code allows to mark the target square with a bit. Single bit basically. I'll demonstrate you that. I'll demonstrate you how this works. So how I've been debugging so far. Also, we'll need to end the recursive call of the search function and wrap this with make move here. Here goes the make move, and here goes the take back. It's probably just a little bit wrong place for it. It's probably make move should be here, but anyway, doesn't matter. So there won't be this code, but there would be this code, and there would be a little bit more code for make move and unmake. So eventually this would be no more than 400 bytes. I believe even less. So we can claim that the mode generator for this chess engine would be in under 400 bytes. So yeah, I think that would be the nice title for a video, because I'm not sure how exactly bytes would be there. Now, if we consider the entire program, because I just can't demonstrate this partially because without the data being loaded, so I really need to make sure that the data is being loaded as well. So this kind of thing. So just copy this entire thing here and paste and assemble. And this time I need to 0. So totally takes now 869 bytes, but bear in mind that there is a whole lot of bytes that are not actually used and just serving as a glue to concatenate this data part and the code part. So the end of the 0 page and the entire stack page are being just mimicked here like this. So maybe I will put evaluation here. I'm not sure, because I don't really want to go above 03FF. So that this program is intended to be working on an unexpanded Kim. And if that is not enough, which I hope that won't be the case, but if that is not enough, I also have 256 bytes in the riot chip. So it should be enough eventually, hopefully. So yeah, now it's show time. So let me demonstrate how this works. So for those who probably didn't see the previous parts when I've been adding features like step by step, I will probably demonstrate everything from scratch. So let's start by generating the moves for a knight. So here I have the 0C stands for white knight, so I'm going to be generating the moves for a knight. So this is the board. On the right you have these square tables for positional evaluation that's going to be used later on. So if I just assemble this and upload and go into 0200 and run, and go to the hex stump, and here we go. So we got our knight here and the 8 directions of where the knight can go. Now, well, probably I'll show how it doesn't capture own pieces and how it captures opponent's pieces on a slider pieces. But trust me, this works on Libra pieces as well. So we'll end up with the pawns. So start with the knight, then the bishop is going to be 0D. All right. So symbol. Okay. Upload 0200 hex stump 16. So we have this diagonal stuff here, and already I can demonstrate. Well, let's actually go for a rook, and for a rook I'll already demonstrate. So what happens if the own piece is encountered or opponent's piece. So for instance, here I say 09, so just goes here and stops, not capturing the pawn. And here, for instance, I put a black pawn, so it captures. So it captures one square here, and not touching the pawn, and goes to the board edges here and here. So if I assemble this and upload in 0200 and hex stump, and exactly, so it captures the black pawn. It captures, it goes here, not capturing own pawn, and goes to the board edge here and here. So that's good. Okay, and just checking out pins. All right, so same for queen. So nothing special really with the queen, but just to give you an idea, so it would just have some additional rays here. So if I just assemble and upload 0200 and go into the hex stump, and we have exactly the same thing. So we also have this diagonal rays, but still capturing the black pawn and going to the right and not touching your own pawn. So I hope that makes sense. Okay, now pawns. So pawns are getting more tricky because, yeah. So first of all, let's consider a pawn somewhere here, for instance. So let's have a pawn. So assemble this and upload and run. Hex stump 6. So in this position, pawn can only go forward. So it's not about to be capturing anything because these squares are empty. Now let's consider the situation that where, for instance, we have a black pawn in front, so it's not going to be going there, but it's going to capture black pawn. It's going to be capturing black pawns to the diagonals. So just to give an idea how that works, 0200 and hex stump. So see, like, it's not going forwards, but it captures diagonally because we have pawns there, right? So that makes sense. Now the very last but not least and really tricky thing to implement, especially bear in mind the miserable amount of bytes being used, is the double pawn push. So in case if we have a pawn here, for instance, and let's make it here, and some pawn would be here. So this should be considering double pawn push, this should be considering double pawn push, but this is not because it's not the second rank. And this also works for black, but it just takes ages to demonstrate. So just trust me that it works for both sides. So just assemble this and upload 0200 and hex stump 16. So we got this pawn go with double pawn push. This is just a single pawn push, and this goes for a double pawn push as well. So everything seems to be working. So the very last thing is we need to return the plus infinity score on capturing a queen. And I'm not yet sure how exactly I'm going to be dealing with the scores for evaluation, because so far I've been using just the highest bit, but probably it takes too much space to implement. So rather probably trying to use the wraparound, the natural wraparound of the integers. So it's not really a matter of what exactly I return as the plus or minus infinity. I just want to give you an idea that if it's about to be capturing an opponent's king, then it's not going to be captured, it's kind of breaks out of the loop. So gives meanwhile given an idea that it's kind of not possible. Oh, sorry, where my camera gone? Always on top. So for instance, so the black kin is 13. So if, for instance, here I have a black kin, and I assemble, and upload, and run, and hex dump, and here we go. So it just goes forwards. However, it doesn't touch the kin. Well, actually, it says that the kin has been touched. And if you have a look at the best score, so here I have a marker AA. So this is the best score. So it says the best score to AA. By default, the best score is FF. So just to make sure that it's different. I didn't show you this before, but you can just trust me. So yeah, kin captures are also handled so that the engine will be capable of detecting checkmates. So yeah, I think this is pretty much all about it from my side in regards to the mode generator. So the next major thing to add to this engine is actually the routines to make and unmake move, but just want to give you an idea how they look in my C prototype. So this is the make move, and this is the unmake move. So it's quite simple and self-explanatory. And then we need to wrap this, use this make and unmake move. Also, we need to don't forget to change the site, obviously. And also, we need to, in between, we need to recursively search and then do this nigemex manipulations with the score, which again currently is not yet on the card. So for now, just be happy with searching recursively. And then I really hope that I would be able to inspect the same thing, but instead of, so far I've been checking out whether the target scores are being generated properly or not, and the next thing I would be checking whether the position is being restored back and forth properly or not. So just to make sure that it's not messing up things and everything works properly. That's it from my side, guys. Thanks for watching. Until the next time, and take care.